Hello everyone. So the lesson prior to this video assigned a Delta Math that had some questions on it that were a little different than what we saw in the notes. The final answers had to be written in a format that troubled some of my students this year, 2025. So I decided to make this video to help support those kinds of questions. Focus of this video will be on using square roots to solve special quadratic equations. Any quadratic that's missing the b term is solvable using square rooting techniques. So we're going to look at 4 quick examples. The last one will be a real messy one, so this should be a good video. Let's get into it. Our objective with each of these examples is to isolate the x squared, or the term that's squared. Maybe it's more than an x that's being squared, but we want to get the squared thing isolated. Right there, I boxed the squared thing. So there is a positive 13 that needs to be moved. We move things using our algebra skills. So this video won't focus on that. It'll focus on the square rooting piece. We still have one more algebra move to make. We need to get x squared by itself and positive. So we'll divide by -1. And there we have it. We have x squared equals 23. To finish solving for x, I need to do the opposite of squaring, which is square rooting. And the critical part of this skill set is to remember that when we use a square root during the algebraic process, we need to account for the positive and the negative value that that square root creates. Go back to the first day of this lesson to learn why that is. But for this video, we're going to focus on the process and how to write our final answer. Because the square root of 23 does not simplify, that is the best we can do. That is a fully simplified final answer. I'll also remind us that that answer has 2 numbers in it: positive root 23 and negative root 23. That's just a more condensed, simple way to write both those answers. All right. In the second example, we are really going to be tested to see if we can use our algebra skills correctly. We are going to first want to add 5 to both sides. We want to add that 5. Remember, addition and subtraction should be done before multiplication and division. All right, at this point, I'm going to divide both sides by 5. See how that 5 is multiplying the entire binomial in those parentheses? So if I divide everything by 5 on the left side, I eliminate that 5. A lot of students want to distribute that 5 in, but in this case, that would actually be a less efficient, messier decision to make. Especially given that on the right side, we have a multiple of 5. So we have a nice number on the right side of the equal sign. With the 5, excuse me, with the 5 gone, those parentheses are also gone. Now I can add the 8. And finally, we have isolated the squared term, so I can square root both sides. Remember that the moment we square root, we get a plus and a minus, a positive and a negative answer. Once again, the square root that we're left with, square root of 10, should be simplified if it can be, but it can't be in this case, so that's as far as we can go. Those are our 2 answers, positive and negative square root of 10. In example 3, the part of the equation that's being squared, the x plus 10, is already isolated on the left side of the equation. Since it's isolated, we can square root right away as a first step. That's going to get rid of the squared. It's going to get rid of that exponent of 2. And it'll leave us with just x plus 10. On the right side, we can square root 49. The square root of 49 is 7. However, again, the moment we square root something, we need to put a plus and minus in front of that value. So there we go. So now what we actually have here are two separate kind of not universes, but two parallel algebra thoughts here. On one side, we have x plus 10 equals, we'll go with positive 7. And then on the right side, we have x plus 10 equals, and then I'll put the negative 7. A plus minus 7 is two values. So if we have more algebra to do to finish the process, we need to do that algebra to both of those values, the positive 7 and the negative 7. So I'll start on the left side. I'll subtract 10. 7 minus 10 is negative 3. That's one of my solutions. Okay. On the right side, I'll subtract 10. Negative 7 minus 10 is negative 17. That's my other solution. All right, here we go. So I picked this example because I think it was the messiest, ugliest example that I could find. So we'll see if it lives up to that descriptor. Here we go. Similar to, I believe it was example number 2, if I'm remembering right, I want to divide both sides by that value out front of the parentheses. I can't distribute it into the parentheses even if I wanted to, because the entire set of terms in the parentheses is being squared. So I can't distribute into something that's being squared. That does not work. Never, ever, ever would that work. So we can divide by 4 on both sides, and that cancels that. Unfortunately, on the right side, 49 divided by 4 doesn't reduce. That's not a nice value. That's a decimal. So 5x plus 7 squared equals 49 over 4 is where we rest for a moment. On the left side, I've isolated the entire thing that's being squared. So if I square root that, I'll cancel the square out, and that's a good move to make. What I do to one side, I need to do the other. Excuse me. So on the left side, I have 5x plus 7, and on the right side, I need to square root that fraction, and lucky for me, that fraction is composed of perfect squares. The square root of 49 is 7, and the square root of 4 is 2. So that does reduce nicely. I need to put a plus and minus in front of that fraction, though, because I've square rooted. So at this point, since I still clearly have more algebra to do, I'm going to split this into two separate algebra thoughts. 5x plus 7 equals, we'll do positive 7 over 2. And 5x plus 7 equals negative 7 over 2. We're going to just go ahead and solve both of those one at a time. Okay. So over on the left side, my first algebra step would be to subtract 7. So I'm going to rewrite this all on one line. I have 5x equals 7 halves minus 7. Well, for a moment here, I'm going to focus on this value right here. Because in order to do subtraction with fractions, we need to have a common denominator. We need to have a common denominator. So I'll create a common denominator by multiplying that fraction, or that number 7, by 2. So what that's going to look like is 5x equals 7 halves minus, and then I'm going to multiply that by 2, so I get 14 over 2. 14 over 2 is 7, but what that allows me to do is subtract. So now I have 5x equals 7 minus 14 is negative 7 halves. Remember, when you're subtracting fractions, just subtract the numerators, keep the denominator the same, unchanged. Just to show the parallel, I'm going to do that same step over on the right side. So I'm going to jump over to the right side. I'm allowed to do that. So my first move on the right side would be to subtract 7. If I rewrite that, I get 5x equals negative 7 halves minus 7. And if I want to subtract 7 from negative 7 halves, I need to create a common denominator. So I get minus 14 halves. There we go. Now I can subtract the numerators. Negative 7 minus 14 is negative 21. And then the 2 stays the denominator. Awesome. All right, let's finish this process. To isolate x, I need to remove the 5. 5 is being multiplied by x, so the opposite of multiplication is typically what I would do. However, in this case, since I have fractions going on, instead of dividing by 5, I'm going to multiply by the reciprocal of 5, which is 1 over 5, of course. So I'm going to multiply by 1/5 on both sides, multiply by 1/5 on both sides. What that does is cancel the 5 out, leaving me with x. And then when I multiply fractions together, like I have right here, I would multiply the numerators, so I get negative 7, and the denominators, I get 10. So there we go. That move will be the same move I make to finish the right algebra thought. I'll multiply both sides by 1/5. That gets rid of the 5. And I get x equals, let's see here, negative 21 on the top and 10 on the bottom. So hopefully you found that example rich and enlightening. If you run into something similar, I hope seeing that example helps give you the tools you need to be successful. Thanks for watching, everyone. Best of luck, and we will see you next time. Bye.